Thanks for joining me here today. This is a deep dive into Microsoft Access in the cloud. Hope you guys are all in the right room because they just locked the door. So buckle up. No, just kidding. This is SVS343 building microservices with AWS Lambda. I've got a lot of content here. Probably going to use up almost the whole full hour here going into stuff. My name's Chris Munns. I am currently Senior Manager and Principal of Developer Advocacy for Serverless here at AWS. I've been at AWS for a little over 7.5 years now across a couple different roles, but basically for the last 3 years completely focused in this world of serverless. And so I lead a team of people who maybe you've had a chance to see speak or lead workshops or read some of our recent launch blog posts this week, but a whole lot of stuff going on in this space. So why are we here today? So as we were ruminating about talk topics and the things that we would talk about reInvent, one thing that we kept coming back to was this trend that we keep seeing in the industry. And it's this idea that somehow the two terms containers and microservices seem to be kind of married together. People kind of sometimes conflate and confuse the two. And I think it's very important to understand that containers are a delivery mechanism, microservices are an architectural pattern, and microservices existed before containers. Containers could be used to deploy monoliths, and so basically the two shouldn't necessarily always be thought of in the same sentence. And so what we wanted to do was to do a talk where we would break down some of this and talk about how Lambda can be used to build microservices. And so again, that's basically the gist and the point for today. Now, in terms of microservices, at Amazon and at AWS, we've been building microservices for a really, really long time. Since the early 2000s. This is a diagram of all of the services that were inside basically Amazon/AWS in about circa 2008 to 2009. And so you can see here many hundreds and thousands of application points. And the black lines basically represent dependencies across them. And so somewhere in the center of this Death Star, if you will, are things like identity services, security services, and user management stuff. And if we were to draw this again today, it would be many times the size of that in 10 years. Another way to think about this, another reference point, is that last year, Maylon, who is one of the VP of Storage Services at AWS here at reInvent, spoke about how when S3 launched first back in 2006, it was made up of 8 microservices. So the very first first version of S3 that you would have consumed back then, 8 different services. And then when we looked at S3 at reInvent 2018, so again a year ago, at that point in time, it was now 235 plus different microservices. So again, over time, we keep expanding and building this out and building this out. And I'd like to say that some number of these are Lambda-based. Like I can't give any direct specifics. But again, when it comes to microservices, we do this a lot at Amazon, and we have a lot of repeatable patterns for it. Now, one pattern that I like to talk about is something that you'll see others in the industry talk about, which is this concept of the microservices iceberg, if you will. And so with the microservices iceberg, there's this idea that you typically have just a single public interface, usually, that kind of sits above the waterline, so in the public range. And then below the waterline, you have all of the other services that that support that public interface and the overall capability of the product. So again, if you think about S3, you're not talking to 235 different API endpoints for that one service. You talk to the one S3 API, and then all those other capabilities are kind of mimicked and hidden behind it. And so I also like to call this the microservices mullet. We've got APIs in the front, party in the back, or async in the back, if you will. And so there's a bunch of, again, common patterns that we see with this. So when we talk about microservices, we're very often talking about API-driven capabilities. So on that front end where we have this more synchronous, direct-to-client or direct-to-customer capability, that's, again, where we're typically using things like traditional HTTP web or mobile clients. We're going to rely on things like API gateways or load balancers to provide access into our actual application that's running. We typically have, again, some sort of rich or flexible client interface. If you think about most HTTP or REST APIs, a number of capabilities, and we're focused on securing against the client. Versus back on the party side of things, underneath the water here with our asynchronous services, and we'll talk a lot more about asynchronous later, we've got much simpler interfaces, typically things that aren't as flexible, very singular purpose. Maybe we're making use of a service to help us with messaging between that front end and that back end. And we'll talk about a bunch of event sourcing that you can do as well. And then again, you're going to have a much more opinionated event and message model. This isn't something that's going to have a lot of different dynamic customers. You could have microservices that have basically one-to-one mappings to each other inside of a larger application. So we're going to kind of follow through a simple model here today of just a very small iceberg. We're going to have one public service, one non-public service, and we're going to talk about some of the options that you have for thinking through this. And I'm going to give a bunch of what I would say are semi-opinionated, I'll say they're heavily opinionated thoughts on how to choose certain technologies. Make of it what you will, but hopefully you get some good guidance to walk away from this talk with some things to do. So again, we're going to have a front-end component, that public component. We're then going to have what I consider the back-end, or again, below the waterline component. And then in order to support the two of these, there's going to be some number of shared capabilities or shared things that we're going to make use of. And so again, we're going to basically fill in these boxes here today with different technologies to serve this. Now, this is a session all about Lambda, so we obviously have to spend a little bit of time here talking about Lambda. So AWS Lambda is a compute service. We first announced it here at reInvent 5 years ago. And so it's in AWS world, this makes it an old dog. It's been around for a long time. Lambda, though, for those of you who are new, have some really interesting, unique characteristics when it comes to building applications with it. They make it different than just building an application inside of, again, a container or a VM or even physical hardware. So again, Lambda is a compute service. We consider it a serverless compute service. What does that mean? It means that it meets 4 key criteria for us at AWS. One, that there is no physical, virtual, or container orchestration that you have to manage in order for this compute resource to work. It's highly available, and it has security built in from the base of it. It also, like many of our cloud services, should automatically scale. That means both up and down without you having to think too much about what's involved in that. And then lastly, we say that with Lambda, there's this concept of pay for value. We talk about pay for value. Typically, it means that when you're not using it, you shouldn't have to pay for it. But actually, just yesterday, we announced a new capability for Lambda called provision concurrency. Provision concurrency helps solve what many of you may know of as a cold start issue with Lambda. And it allows you to basically pre-warm a certain concurrency capacity for Lambda. Now, you end up paying for that, so you are essentially paying for the value of having that available. But again, it's a little bit of a tweak to the model for Lambda. And again, this was just announced yesterday afternoon on the Twitch Launchpad. Now, code inside of Lambda is deployed in a unit that we call a function. And typically, we think of functions being very granular, very purposely built, very much aligned with a very single or small number of use cases. And we'll talk about that a little bit more here as well today. Then it also has some other unique characteristics that come in the form of effectively limits in the function. So today, a function can have anywhere from 120 megabytes up to 3 gigabytes. It has a maximum 15-minute duration for a single execution. The application artifact can be a maximum of 250 megabytes, and we give you another 512 megabytes worth of temp storage. Now, there are some other limits that are out there around things like open file handles and some other stuff, but we're not going to get too in deep on that today. Now, the unit of a function also has a number of characteristics towards what you can configure with it. So things like security, which we'll talk a little bit here about security, but you can make security and performance controls very granular to the function. And so it gives you the ability to get, again, really fine-grained across your application. But there's another key point that you really have to understand about Lambda, which is the fact that it is an ephemeral environment. So what this means is there's no ability for you to, say, have a sticky session down to a Lambda function. It's a really poor practice to store any sort of important stateful information in there. Because what we do is we run a massive pools of compute, and we execute your functions on those. But we basically, every now and then, churn them out, reap them, as we call it, behind the scenes. And so there's no way for you to be able to store state on a Lambda function and repeatedly get to it for any prolonged period of time. Now, with Lambda, you pay, in the original on-demand way, per invocation, and then for the duration of the function. In the new provision concurrency model that we just announced yesterday, you also have a provision concurrency rate that you pay, but the execution or the duration cost is actually greatly reduced. So if you actually use provision concurrency really well and it has a heavy utilization, you actually save money on your Lambda workloads versus what we now consider on-demand model. The other thing that makes Lambda really unique is that there's no concept of a socket or a port for Lambda. You can't directly talk to it on the network. You can only access or invoke a Lambda function via its API. And so because it has this event API-driven model, again, you think about it a little bit differently than if you were running, say, an application on a container and you had a sidecar, or you had something like Nginx or something else that would be presenting out the interface to that. You can only talk to Lambda via its API. And we support two core models in how you can invoke Lambda functions, synchronous and asynchronous. And so you do have, again, a couple different ways that you can use it. Now, when we talk about a serverless application, there's basically three components that make that up. There's some sort of an event source. Today we have over 100 different services at AWS that can either directly or via SNS or EventBridge or another service invoke Lambda. And this represents everything from endpoints, so we'll talk about API Gateway here in a little bit, but also services like Alexa, some of our IoT services, changes in databases, so DynamoDB, for example, and then also in responding to events that happen inside of your infrastructure. So this could be dev tools, management tools, security tools, all sorts of things that can directly invoke Lambda. That will then go cause, again, an invocation, essentially running of your code. Today with Lambda, we support 6 languages that we manage for you. So Java, Node.js, Python, Go, .NET, and Ruby. We also have something called a runtime API, which allows you to bring pretty much any language that you could think of to Lambda. So we have customers running things like PHP and Swift, other JVM languages and stuff like that. And the last, whatever it is that your function does, talking to different databases or data stores, that's entirely up to whatever your business logic is. Now, we're not going to spend really any time here talking about different databases or data store options. The scope for that's a little bit too big. But what I do want to share is that also just yesterday, we announced great improvement to being able to make Lambda work with your relational databases. In RDS announcing something called RDS Proxy. And so what RDS Proxy does is it does connection pooling and management for databases. And so you can connect your Lambda function to an RDS Proxy, and then the RDS Proxy to your database, and it greatly helps reduce the amount of connection management that you would have had to done previously before we launched the service. So really, really big improvement in terms of database connectivity with Lambda. So again, this is a talk focused on Lambda. So we're going to make Lambda be both in the front end and the back end of our microservices architecture. But the next thing that we have to figure out is how are we going to front our Lambda-based API? Now we've got a couple different options here at AWS today for how you can do this. I'm really happy that the slide didn't get out of date from Monday till now, although it did a little bit. So I'll talk about some really exciting stuff here for API Gateway that literally before I walked in the room, we just published the launch post for. So you're the first people to hear about it, I think, in person today. So 3 different options: Amazon API Gateway, Application Load Balancer, which is part of the overall load balancer family that we have here at AWS, and then AWS AppSync. And again, all 3 of these have the ability to represent what we consider an API out to our end client. Now, with API Gateway, I say here that we have 2 different types of APIs that we support, but we just announced a 3rd. So we have REST-based APIs, which is the first type of API that we announced API Gateway for, and then we added WebSockets last year. Just today, we announced basically a new version of APIs that we call HTTP APIs. HTTP APIs are a bit of a simpler way of doing what you could do with REST APIs before. It's 70% cheaper than API Gateway was previously for REST APIs, about 50% of the overhead that you had on top of it. It also has a bunch of new capabilities around different authentication models, better core support, a number of other things that we think is going to make this pretty exciting. So this is, again, brand new. It's in preview, but you can check that out after you leave this talk if you want. But with API Gateway across both REST, WebSocket, and now this new HTTP model, we have a number of other things that basically are pretty standard for it. We've got caching, we've got throttling and usage tiers. We can do things like client SDK generation. We support a couple different types of API endpoints. So we can do what are called edge, which include a CloudFront distribution, regional, which as the name sounds, are available public within a region, and as well as private APIs. So for things like internal microservices inside of a VPC. And again, we've got a bunch of talks this week that go a little bit more in depth than this. So SVS343 and SVS343. If you don't get a chance to catch them this week, definitely check by the end of the week or next week when the recordings and slides are made public. So that's API Gateway. And again, big new announcement here today just coming out about lower costs, faster, a whole bunch of new features. And we think that folks are going to be pretty excited about that. The next is Application Load Balancer. And so Application Load Balancer, again, part of the overall load balancer family that we have here at AWS. It just supports HTTP or HTTPS-based endpoints. So it doesn't have any sort of opinionated interface around REST or WebSocket or anything like that. It's basically just going to forward an HTTP request back to a Lambda function. It supports a concept of path-based routing. So what this means is you can have a single ALB, and you can have some part of your site or your API live in, say, containers or EC2, and then some part of it in Lambda. So it can be really good if you need to mix model some of your application for some reason. Allows for things like URL redirects, custom HTTP responses, and again, it can integrate with more than just Lambda, which technically API Gateway can as well. Now, the pricing model for this, and apologies, I didn't say what the pricing model was for API Gateway. It's per request and data transfer. For ALB, the pricing model is per hour, so you pay for a time period, and then for something called an LCU. And so an LCU is kind of an interesting metric that combines things like connections, data transfer, and a number of other things. But it's a little bit of a different pricing model for how you think about hosting web services. And finally, we have AWS AppSync. So AWS AppSync is considered part of the mobile family here at AWS, and it's just kind of by organizational where it lives. But it's actually a really flexible service, has a lot of capabilities. Now, AppSync is built to host what are called GraphQL-based APIs. GraphQL is kind of, I'd like to say it's kind of a slightly newer technology in the industry, but really it's been out for a number of years now. Facebook uses it. Companies like Starbucks have started using it very heavily. And it's a pretty cool technology that allows you to take a single API and be able to map it back to many different data sources, different data tables, and write really, really rich queries that have the ability to pull data from multiple places in a single query. So with AppSync, I could write a query that gets data from DynamoDB, from Elasticsearch, from a Lambda function, from a relational database, and present that back as a single response to my client. So as opposed to a traditional REST or HTTP-based API where I might have to say, get information about one thing, get information about something related, get information about something related, I can pull all this information in with a single GraphQL request. So AppSync has, again, a bunch of different capabilities. It can talk to a number of different backends, including Lambda, including relational database, including DynamoDB, Elasticsearch, I believe a couple others. Has really deep integration with something called the Amplify framework, which is a front-end and mobile framework that we have here at AWS that itself is also really powerful. So we can do code generation, a number of other good stuff like that. And it also supports a concept called subscriptions and then offline sync, which can be really, really useful for mobile applications and being able to handle clients that come and go and data that might be between different apps. And then much like API Gateway, it basically has a payment model that is per query and then data transfer. Now, if we look at the three of these, there's a chance that any one of these could solve the problem that you need to solve. So sometimes it can be difficult to give really direct guidance on what is the right choice. But what I've tried to do is give kind of a very simple, what I call cheat sheet to how you can think about these. So if you have a really complex, rich API that maybe needs to talk to multiple data sources or support really complex queries across data sources, then AppSync could be a good one for you. And again, GraphQL is becoming a really strong industry standard if you haven't looked at it or aren't familiar with it yet. If you need WebSockets, then Amazon API Gateway is probably your best bet. So we have WebSocket support in API Gateway, which is really cool. We see this being used in IoT applications and real-time applications, dashboards, chat apps, all sorts of things like that. If you need to do anything that might involve you interpreting the request or the response, doing what we consider a transform on it, so adding data, taking data away, changing things like that. If you are exposing an API out to third parties that maybe you don't control, so if you're going to expose an API to customers and charge them for it, and they can design clients against it, where you need to care about throttling and usage tiers and advanced security controls, then API Gateway is definitely the best option for you. You're going to want to go with that right away. However, if you have a really kind of basic, straightforward API, you want to do more of the ownership of those things in your own code base, and you potentially have a really high throughput, then ALB might actually be the best bet for you. And we can find that at really, really massive scale, ALB could be a little bit cheaper. Now, this is up until the recent announcement today with the new HTTP type of endpoint for Gateway, whereas now I would say the cost changes a little bit. But again, with ALB, a little bit simpler product, a little bit different pricing model at scale that could be, again, a little bit cheaper than API Gateway was. And then lastly, this is kind of the catch-all. If you have, again, a pretty standard API, it's maybe not massive scale, and it doesn't have necessarily a ton of, again, some of these other unique capabilities that you might need, then just starting with API Gateway is a good place to go. And again, I would say with the new HTTP API support that we have, this could be a really great option now for some of these other aspects to this. So for my front end here, I'm going to go with API Gateway, and it's going to, again, invoke my Lambda function on my behalf when we get requests. Now, real quick about security, and this again goes for the REST and WebSockets, not for the new HTTP API Gateway capabilities, which we just announced about 2 or 3 hours ago. Various different options that we have for authorization out to my client, so out to my mobile or web or whoever might be consuming this API. So obviously I can leave it open. Probably don't want to do that, but there could be use cases where I do. I could use AWS Identity Access Management, or IAM, which probably hopefully everyone in this room knows is one of the core services that grants roles and permissions and access to services at AWS. I could use a service called Amazon Cognito, which allows me to create either a federated or a user pool to manage the users. And then lastly, I can actually use Lambda as a custom authorizer for my API Gateway. So I can use custom logic in Lambda, maybe tied back to a different user management service or some sort of other way of managing my users with my API Gateway. Now, one topic that I want to touch on real quick here is something that I think is very unique to what we have here with Lambda and API Gateway put together. And so assume that we have an API, and with our API, we've obviously got a number of different, essentially routes or actions that we want to take inside of that API. Now, for some of you, this could mean a couple different things, but one question that we often get is, where should I think about doing the actual routing of how I handle this? Now, one thing that we see increasingly is that a number of the third-party language-based frameworks that are out there will actually want to do this inside of the Lambda function. So if you look at things like Spring Boot, if you look at Flask, a lot of those have built-in routing capabilities inside your code. So again, one option here is that we could use the built-in capabilities of API Gateway, where we could map an individual route back to, say, an individual Lambda function. We can do this very granular. We can do this on the method and the action level. So we can have a whole lot of Lambda functions, very, very small, focused on a very small use case of my API. And then if we thought about doing this the Lambda way, and again, this is typically done with certain language-based frameworks, what I would do is basically proxy all of the requests just to a single Lambda function, and then have all of the code and all the capabilities inside of my one function. And so there are a number of people who like to do this. Now, this can work out pretty well. There are some benefits to it, but I also want to highlight some of the characteristics and concerns of it. Now, again, when you do this, you have effectively what I like to call the Lambda-lith. It's a large monolithic Lambda function that has a lot of capabilities built into this. And again, for some of the frameworks that you see, they will say this is the way. But again, some of the challenges that you have here is that you essentially end up, again, treating this one Lambda function as the entire application. So things like security and performance now apply to the whole. You can't configure a per capability IAM role or Lambda configuration for performance. You still have the same limits around the total application size for your function. So again, that 250 megabyte artifact. So if you end up having a really flexible, or a really, I would say, complex, capable API where you have to include different libraries and third-party packages, all of a sudden you can max out that artifact really quickly. The limited duration of your function, so again, you still max out at 15 minutes. Typically not that much of a concern with an API. If you have a 15-minute long-running API, you're probably doing something pretty unique. And you probably have a really unique client for that. But again, these are a bunch of some of the trade-offs that you want to think about. And so I really see kind of two different types of thought processes, again, in this kind of consider this like a two-team type of an option. Again, with Team API Gateway, you're saying, I want to use the built-in capabilities of API Gateway to handle basically what it's meant to do. So maybe I need transforms, maybe I need very granular permissions or very granular performance settings that I want to set, and you only really do that with API Gateway in front of Lambda. This is also going to have better capability with AWS's tools, so things like CloudFormation, AWS SAM, Amplify framework, all of those things are being met more for this model. However, on the Lambda side of things, you still get some benefits. So again, you can make more use of the full capabilities of some of these third-party frameworks, and some of them are incredibly powerful. And you might have been using them for a while now, and they're just ingrained to how you develop applications. And we like to say that if something's working for you, don't change it, unless there's a strong benefit or reason why. You could find that it potentially allows you to have essentially better code portability. Now, for some folks, this is a big thing that they care and they're concerned about. And so if you use a framework and it allows you to pick up that code and run it in a container or run it in Lambda, then that could be a benefit that you care about. The next is that you have fewer security constructs. Now, I just said that this was potentially a con of this model, but one of the common bits of feedback that we get about the previous model is that you end up with a lot of sprawl of IAM roles, IAM policies, configuration that you have to manage. And so with that sprawl of all of that configuration and all of those things, you do have a little bit of overhead in the overall management and construction of that. And then lastly, one of the things that's been passed out there about this is that it can lead to fewer cold starts. So again, for those who aren't familiar, the cold start is basically this concept of when we get a request or we get an invocation from an event source, we have to find an available compute source that's aligned to your account, that's running your application code to handle that. And if we don't have one, we have to then take from an available pool, pull your code into it, bootstrap that environment, and then execute it. And so that period of time there is called a cold start. And so one thought is that if you have all of your code inside of a single function, then you would potentially have many fewer cold starts because it would just continue to reuse that same function over time and across all the various capabilities that you have. However, Jan Kui, who is one of our community heroes focused on serverless, wrote a blog post about this, and he found that it's kind of a toss-up. It doesn't always really work out that way. It really depends on your application patterns. But there are some folks who say that this is a big benefit for it. So which one should you choose? What is the official guidance from AWS? Fortunately, the official guidance is that it's really kind of a toss-up. We don't really have the ability to say, always do this. And again, the one thing that we don't like to do is tell you, oh, no, stop everything that you're doing that works for you. Take all that development experience that you have and these frameworks that you love, stop using them immediately, they're wrong. So again, if you have a framework and it works for you, or you see one that's interesting and it's going to make your life easier, or you really care about portability between different types of compute environments, then by all means stick with your framework. If you want to make better use of the managed services, be able to use more of AWS's tools and some of the other ones in the serverless ecosystem, then you're probably going to want to go the API gateway route. So again, a little bit of, again, some opinionatedness on this, but generally speaking, this is what I see being the overall kind of outcome of these types of conversations with customers. Okay, so let's move on to the next section about this, which is taking this front end and then connecting it back to our back end. So we're going to talk about the number of different ways that we could do this. And now again, we have a couple different options, right? So we're going to have API gateway talking to our Lambda function on the front end, and then we need to talk to this back end Lambda function. Now we could basically just have Lambda talk directly to Lambda. So we could have Lambda call the Lambda API to invoke that other function for us. And today with the AWS SDKs, this is built right in. So we could call it either synchronously or asynchronously. But the challenge becomes that then we have to write code to handle things like failures, retries, across a number of different scenarios. And so there could be complexity in that we don't want to have. Now, another thing here that we see is that people often think about this type of a model synchronously. It's one of the biggest challenges we have with working with customers around application architecture is this kind of strong historical adherence to thinking about synchronous applications. So let's talk a little bit about why that's not necessarily ideal. So if we have a single service, pretty straightforward, that if we make a request to it, we get a response. And if for some reason something went wrong with that first request, pretty traditional HTTP practice is just retry, right? And so we could build this into our client, we could build this into our browser. There's things that we can do to handle this request and be able to recover from it. But now when we start talking about distributed systems or microservice-based architectures, we end up adding a bit more complexity to this. So if we take our first service, the order service, and we say, oh, when you place an order, it's going to then call the invoice service. And then if we were to do this in a synchronous manner, the invoice service would apply back to order service would apply back to our client. And this doesn't just add one extra step point where we could have failure. It actually adds a couple different places where we can have failure. And so we have to think about the communication between these services, the communication back up to the client, where we think about where failures might be, how we think about handling that, idempotency, tracking, all sorts of stuff. And so we start to have to think about, well, who handles that failure? Who tracks that idempotency? What does the client see? What does the client not see? And so pretty quickly, this again becomes a lot of complexity that we typically want to avoid. So with asynchronous architectures, again, what we're looking to do is basically have that first service call the second service, but then immediately respond back to the client and say, hey, I'm done here. That's all good. Now, what this means is that you have to design your application to handle this. And so the solution to going again and connecting our order service to our invoice service is that what we would do is then if client cared about the invoice, they would have to go and pull that invoice service and get that information or something like that. And so I was looking for a good quote to kind of summarize some of my thoughts about this, and so I found this, and I think it's really impactful. You guys are slow. I know it's day 3. Come on, it's day 3. It's a joke. It's a joke. They give me these slides that they call it quote slide, and I was like, who am I going to quote on this? What are you supposed to quote? But anyway, again, what we find when we work with customers, again, tough audience. I know it's day 3, but when we work with customers, we find that when we actually stop and try to break down these workflows, talk about synchronous versus asynchronous, it starts to really open up thoughts about how data flows through your applications, how to think about microservices and distributed systems. So again, pausing to think about, do we really need this to be synchronous, or can this be asynchronous, can be a really eye-opening experience to how you do application design with distributed systems. And again, for us at AWS and Amazon in general, we do async in so many different places. If you place an order off of Amazon.com, you very quickly see all the asynchronous aspects of the fact that we say, hey, yeah, we're going to process this order. And then a couple minutes later, you might get an email that says it's been processed, we've charged your credit card, we're going to do this, we're going to do that. And that's a whole lot of async that happens behind the scenes. So when it comes to doing things async, if we don't want to control the client ourselves, what we then have are a number of different options for connecting, again, our front-end service to what we're calling our back-end service. So 4 kind of primary services here: Amazon Simple Notification Service, so Amazon SNS, Amazon Simple Queue Service, or SQS, Amazon EventBridge, and then Amazon Kinesis Data Streams. Now, these 4 products by themselves are super rich. There's a lot of different capabilities. There's a lot of things that we can go into about them. When I think about working with customers through this, a lot of times I come down to basically 6 key characteristics that we can compare them. So we can think about how scale and concurrency works with them, how the durability of messages that are placed into them or events, the persistence, and persistence and durability are 2 different things in this case. Consumption models, so is it push or pull based? Thinking about things like retries, and then of course pricing. And all of those matter, and all of those are factors that you'll want to think about when you're designing your applications. Now, fortunately, we don't always make this easy for you. In the last 2 weeks, we've announced a whole ton of new capabilities for streaming and async events. And so if you want to throw a camera at that QR code real quick here, you'll see our serverless pre-event blog post that we put out right before Thanksgiving here in the States last week. It contains about 30 or so different launches from just the last 2 weeks that are impactful for serverless developers. And we've got a lot of depth and a lot of material on these, links to a lot of other launch blog posts and stuff like that. So one is that we just announced SQS FIFO support, so first in, first out queue support. This has been a big thing for folks that try to track transactional or ordered events, now directly built in with Lambda. We announced something called SNS dead letter queues. So dead letter queues basically allow you to capture when there's been a number of failures that come from SNS to a Lambda function. We announced a new capability of Lambda called Lambda Destinations. And this is kind of a next level of dead letter queue where after an asynchronous Lambda function has finished being invoked, you could capture either the success or failure of that, send it on to either another Lambda function, an SNS topic, an SQS queue, or to EventBridge, and then further process it. So there's a bunch of capabilities with that as well. And then for streamed and async events, a whole bunch of new controls. A bunch of controls around retries, a bunch of controls around failure handling. For streamed resources, we can do things like break apart the batches that we used to process. And so for those of you who maybe are familiar with Kinesis, there has historically been this concept of a poison pill record. And what this means is a record that for some reason you can't successfully process, where because we poll on your behalf, it tries to process the event, it fails, so it puts the message back into Kinesis, and then we poll again, and we get the message, and it fails to process. And it keeps doing this for a little while, and so we actually have a kickback mechanism that says, okay, stop processing this stream, something wrong has happened. Now basically you can force out poison pill events to, again, either a destination or just fail them out with some of these controls that we have here. So a whole bunch of scale controls, whole bunch of different things that you have here, all brand new. If you've looked at this stuff in the past, and it's been a while, I would definitely encourage you to check out some of these new capabilities and controls. We also, and apologies, this was not last night, this was actually Monday night at the Midnight Madness, also announced a new capability of EventBridge. So EventBridge now has a capability for what's called schema discovery and registry. Again, with EventBridge, what this allows you to do as a service is the ability to take in a message and then fan it out to a number of different services based on a really granular rule capability. What schema registry does is it allows you to track the messages based on the schema format and register them against the EventBridge. And then what also is cool is that we now also give you the ability to generate code that could process those events. So the code bindings that we have here now that are integrated in most popular IDEs and some of our other tooling will actually allow you to say, give me the code that processes this event. And we give you the ability to pull attributes out of it very easily based off of what the schema looks like. So this is going to help make event processing even easier by giving you literally the code to do it yourself. So again, this just came out Monday night technically. So again, another impactful quote here. So again, a lot of cool stuff here in the last 2 weeks. Something that I heard yesterday was, hey, Andy didn't mention serverless at all in his keynote. And yes, we were a little bummed about that. And you're going to hear Werner's keynote tomorrow, and you'll be like, Werner's not talking about any big launches for serverless. And it's because we did so many of them in the last 2 weeks, and then we've had a couple here yesterday and today. So again, a lot of this stuff is happening outside of the keynotes, but definitely would encourage you to check the Compute blog and the AWS blog to read up on these, because we've got content in both of those places for it. So here's our cheat sheet for how to think about these. Again, this is a very simplified way of thinking about it. So if you have really massive throughput, taking in a whole lot of data, and maybe you care about the ordering of that data, so there might be some sort of sequence tracking to it, then Kinesis data streams is really the way to go. We see this being used for things like clickstream data, log data, or like sensor data from devices. We see this being used in financial transactions, all sorts of things. If you need to do mostly unidirectional, slight maybe fan out, primarily just to Lambda or HTTP-based targets, then SNS could be the best option for you. If you need to pull in a whole lot of data, maybe you can't process it all at once, might need to buffer for some period of time, that's what SQS is here for. And again, that could be ordered or unordered now that we have FIFO support. And then if you need to do fan out and reach to potentially lots of different services, maybe you need to take in an event and you want to record it to S3 so you could do BI on it. You want to send it to a Lambda function to process it. You want to pass it into one of our AI services to do, say, some sort of anomaly detection on it. Then that's what you'd use EventBridge for. And again, this is a really big topic. We're talking about 4 really big services themselves. We had a lot of sessions and have a lot more sessions tomorrow that go into a lot of the details on this. So if you're not already planning to attend one of the talks on synchronous events or asynchronous eventing or architectures like that, then I would encourage you to check out one of these talks or at least follow up next week once they're all posted. Now, one of the things that I really love about EventBridge, which we just announced over the summer this year, is that it can actually talk to all these other services as well. So you could take an event into EventBridge and then pass it to SQS, SNS, Lambda, Kinesis, and again, a whole bunch of other services. And so for that, just given its flexibility and some of the capabilities it has now with the service, with the schema registry and discovery, code generation, I'm going to put EventBridge here between my front end and my back end. So again, this takes care of the front end and the back end. What we're kind of left with is thinking about the shared capabilities that we're going to need to focus on. So now when I'm talking about shared capabilities, I'm talking about the various services that will allow us to make this be a really successful architecture. And so there are things that we need to think about like secrets and configuration management, simplifying ideally, hopefully our code management, debugging, troubleshooting, performance, security controls as well. So one thing that we have for being able to distribute out configuration information and things like database credentials or passwords or API keys, feature flags, stuff like that, is environment variables in Lambda. Now these are just traditional standard environment variables that you can consume directly from essentially the underlying operating system that the function runs on. And so you use the normal APIs or capabilities of your programming language to read those. So for example, with Node.js, it's process.env, it's os.environ for Python. Again, whatever your language of choice is, it's just the normal standard environment variable reading. Again, these are key value pairs. They can obviously be encrypted with KMS, but the one thing you want to keep in mind then is that you then have to enable your function to read keys from KMS. You have to include the client to decrypt things. So it becomes an extra step during the initial kind of init process of your function. And so again, this can be really useful for doing things like creating individual environments and adding some dynamicness to your code. But one drawback is that it's configured per function. So in the model where we have API gateway and then many Lambda functions behind it, you're potentially having to configure each one of those Lambda functions environment variables. Another option that we have to centralize this is AWS Systems Manager, Parameter Store, and then a close kind of cousin product called Secrets Manager. Now, Parameter Store, as the name might sound, allows you to store parameters in a centralized way. It supports a hierarchy, which allows you to do things like create, say, like a per environment hierarchy. So you could have dev, stage, and prod, and then under there have individualized, say, parameters that are for certain applications or certain needs. And then these can be made available not just to Lambda functions, but to your applications running in containers or EC2 or really actually anywhere. If it's just an API that you connect to. A whole bunch of capabilities that you see listed here. And then accessing it via code is really, really easy. You use the AWS SDKs, you call the get parameters command, and then you get back essentially an array of those parameters that you can parse through. Okay. And then Secrets Manager, which again is a close sibling product, as its name might sound, allows you to manage secrets. Now, the key difference between Secrets Manager and Parameter Store is that Secrets Manager is really deeply integrated with a number of our database services. So the RDS proxy that I mentioned earlier directly integrates with Secrets Manager. So you can have Lambda to get your secrets from Secrets Manager to connect to your database, and you never need to hard code any of your username or passwords in your functions, in your configuration, anywhere else. And then about a year or so ago, the Parameter Store team made it so that you can pull Secrets Manager secrets via the Parameter Store API. So with just one API, with just one client, you get information from both of those sources. So again, that's how to do configuration secrets management. Now, when you start adding in all these different capabilities to your function, what you find is that your function typically has what I consider to be 4 different types of code inside of it. You have typically, with most languages, some sort of dependencies, so third-party modules, open source modules, maybe shared modules inside your organization. You've got things like configuration information, helper functions, and stuff like that that you might want to call during the init process of your function. You then have your handler, which is where you kick off the execution of your business logic. You might then again have some helper functions to pull data out of, say, Parameter Store, or connect to a database or something similar. And then you're going to have your actual business logic. And we typically encourage that you separate out your business logic from your handler for reuse and other benefits. So if you take that API that we have again, where we're going to use API Gateway and we're going to have separate routes, we now all of a sudden have a number of Lambda functions. We've got 4 different types of code sections in our Lambda functions. And they're going to do things like talk again to Secrets Manager, Parameter Store, our database, whatever it might be. And so all of a sudden, as we think about the complexity of our API growing, we're realizing that, wow, we might have a whole lot of duplicated code between all of these functions. And so we want to simplify that. So one capability that we have, or I say the capability that we have for solving this, is called Lambda Layers. Now, what Lambda Layers allow you to do is to create a shared artifact that can be configured across multiple functions. And this becomes an artifact that lives outside of your application code, but can contain all of the same types of data that your application would. So dependencies, configuration files, function code, and then basically what happens is this gets squashed down onto the operating system with your application when you have a function be executed. So it could be really a great way to share things. You could share across accounts inside of an organization. You could publicly publish layers. There's all sorts of things you could do, but it basically becomes a sharing and reuse model. Now, a couple things about layers. With layers, you can have up to 5 of these configured per function. They do count towards the overall application artifact size. So again, that's a maximum of 250 megabytes today. So as you add stuff to layers, you potentially lose that space in your artifact. And now layers are, at the end of the day, and we consider an onion file system. What that means is that basically each layer that you configure gets squashed down on the one below it. So it's one single file directory space / OPT on the environment. And so everything gets put into that. Now, this has a number of, again, interesting characteristics. Again, it means that you would overwrite files as you stack these on top of each other. Now, this can be really useful if you, say, have one layer that has a whole bunch of shared dependencies or code in it, and you say, I need to update one file on this. What you could do is publish a layer that has that one file and basically add it to your function, and it will overwrite, essentially cherry pick on top of that other file that was in the original layer. And so there's a number of interesting tricks that you can do with this as well. And so basically what this allows us to do is take all these different functions that we have and remove 2 to 3 of the parts of the 4 different types of things that we'd have in our function, make them just layers, make them reusable, and again, simplify the actual work that we're doing inside of our Lambda functions. Now, when you start talking about distributed systems and you start talking about profiling and troubleshooting across these, it's going to require a specialized tool for it. So here at AWS, we have a service called AWS X-Ray. AWS X-Ray is a profiling and troubleshooting tool. It's directly already integrated today with Lambda and API Gateway and a number of other services with a bunch more planned. With Lambda and API Gateway, it's basically 2 checkboxes. You can see here, I've got little screenshots of it. And then for Lambda in particular, and apologies if this code sample is a little harder to read in this room with the lights up, but basically it's a single line to include the X-Ray SDK, and then another kind of little bit of code that would wrap around the AWS SDK. And then this is going to capture information about every AWS SDK call that you make. You can also use this to capture database requests, so things like MySQL, Postgres, and other databases. So this gives you a whole bunch of information. We could do things like capture and see, well, actually, if we could see the service map that you see here, this diagram with these circles that will show us failures and latencies and paths throughout our application. We can also see basically a waterfall flow of what happens inside of our code. And you can customize your code to put in certain what are called subsegments that will create even more of these blocks of information. So X-Ray, pretty powerful tool. There's a whole bunch of other capabilities that you can do around kind of tracking performance over a long period of time, seeing outliers, being able to look at how various requests have been compared. Much like with the sync and async stuff and streams, we've had a whole bunch of announcements in this space. Now also with Lambda and API Gateway and almost everything at AWS here, we have CloudWatch integrated. So CloudWatch has metrics, it has logs. But actually, the CloudWatch product space just grew pretty dramatically in the last 2 weeks. So CloudWatch just announced something called Service Lens. You can think of Service Lens as a single pane of glass that you can use to view information about your applications. So you can look at an entire serverless app in one window, see all the metrics and everything overlaid. They also announced something called CloudWatch Synthetics, which allows you to basically create a outside of application monitoring agent or testing agent for your application. Really, really powerful for API-based workloads. So there's a concept called a canary. Canary executes a script, and that script can execute against your API or your application and test it for you. And this is in preview. Then again, we've had a whole bunch of other things that have been announced. This thing called embedded metric format, which allows you to create a log entry that also generates a metric for you in CloudWatch. Something called CloudWatch Contributor Insights, which allows you to see things like top talker patterns, top most trafficked endpoints, and a bunch of other things like that. It's pretty cool. A concept called X-Ray Trace Maps, which actually takes this kind of map that you see here and allows you to see it for a single request. So basically, give me one single request, show me all of the paths that it made through my architecture, and allow me to dive into how each service handled that. Really powerful. And then lastly, X-Ray announced integration with synthetics. So you can have these test agents that are testing your API, and X-Ray will report back their performance on them. So you give the ability now to see how X-Ray works directly with this. So a whole bunch of capabilities again here. This is all on the pre-event blog post that I mentioned earlier, and links to docs and blog posts and stuff like that. Now, one other really important capability that we have in Lambda is kind of an interesting, what I consider to be safety mechanism. Now, one thing that we see is that Lambda has the ability to scale really, really large, really, really fast. It can go from doing 0 to thousands of concurrent requests kind of in the blink of an eye. Now, one of the challenges with that is that many of your downstream services can't do that. And so we have definitely seen situations where people have been like, deployed my awesome Lambda serverless app, got a bunch of traffic, DDoSed my database. What do I do now? And so you can think of basically per function concurrency controls as giving you kind of a bounds for how large your function can scale. So it puts a cap on the concurrency that your function can execute upon such that you aren't DDoSing your downstream database, or you aren't maybe hitting a third-party API to where they rate limit you too far. And then it reports upstream to whatever's invoking it saying, hey, this is throttled because it's at concurrency limits. Another cool capability of this is, let's say that you're doing you've deployed some code downstream or to another service, and it's broke, and your Lambda function's hammering it nonstop because its upstream service is sending data. Maybe you have, say, something pulling off of Kinesis or off of an SQS queue, and it's getting records and trying to talk to this HTTP endpoint that's now down. You can effectively use this as a kill switch, which says, hey, stop pulling records, stop executing functions, and later on you can turn it back on again. And it doesn't involve you to change the configuration or break your function or do anything like that. So per function concurrency controls, another really important part of Lambda, especially again in this distributed microservices architecture. Cool, let's talk briefly about security. We always talk about security being the #1 priority for us here at AWS. I like to say friends don't let friends do star actions for different services. This is how you get yourself in trouble. With Lambda in particular, we have kind of two different security constructs. We have the function policy, and this basically says who has the ability to invoke this function. Is it an API gateway that I've configured? Is it S3? Is it Kinesis? Is it other accounts? Stuff like that. And then we have the execution role, which is similar to EC2 roles, container roles, things like that. It's what can the code in this function talk to or access on the behalf of the code. So this means, can my code write or read from DynamoDB? Can it store data in S3? Can it call AWS APIs? And this is where you can kind of get yourself into the danger zone. And this is where we've seen organizations in the last year or so who have had security incidents. This is where it's impacted them because they've potentially had execution roles or in the case of things like EC2, again, these policies that are too broad. They're using star when they should really use really fine-grained policies. Now, all of this is based in IAM, and IAM requires somewhere between a doctorate and an expertise in Dead Sea languages to completely master. I would never consider myself an IAM master. That's a scary type of knowledge, I guess. But it's super powerful, it's super flexible. There's so much you can do with it. We want to make that easy for you. So we have a tool called AWS SAM, which stands for Serverless Application Model. This is a template-driven service for building, managing, deploying serverless applications with Lambda. It integrates with API Gateway, integrates kind of across the board with a number of different services. And so what we can do is we have here, which is basically 20 lines of, in this case, YAML. And what this 20 lines of YAML is going to do is it's going to launch a Lambda function, configure API Gateway, configure a DynamoDB resource for us, and then glue all of it together with IAM. And if we were to write this in raw CloudFormation, it would be about 5 or 6 times the amount of code. So again, SAM really, really simplifies this. Now, one thing that's kind of hidden in here that's hard to read, given those 20 lines, how they're scrunched down, is something called a policy template. So with this policy template that's inside this document here, I basically have 2 lines. One line says the name of a policy. So this policy is called DynamoDB read policy. Pretty descriptive. It's going to allow me to read from DynamoDB. The second line here is the attribute that says which resource can I read from. In this case, it's a table name referring down to another table that I create inside of this template. Now, this is behind the scenes going to expand into a full IAM policy that's been written specifically just to allow me to read from the resource that's passed in. And so with policy templates, we've got a little over 50 different, last time I checked, policy templates that exist that are pre-scoped for the most common use cases for serverless applications. Reading and writing from S3, from databases, from queues, talking to certain management APIs, and certain other capabilities where you want to be sure that you're scoping it down to a specific resource. Now, even if you don't want to use SAM, if you're using serverless framework, if you're using just raw CloudFormation, if you're using Terraform, one of the cool things about this document that you'll find here on this link, which lives up in GitHub, is that it's basically an IAM best practices cheat sheet. You can go in here and say, okay, I'm using Lambda this way. What are the permissions that I need? And this has it written out exactly as you would need it. And you could just transfer that policy to whatever tool it is that you might be managing it from. And again, you can find this in the repo in GitHub for serverless application models. Now, one other part of SAM is that we have a tool called the SAM CLI. This is a local development testing management tool for serverless. I don't have a link to all the new stuff in this, but we basically have launched a whole bunch of new capabilities in this also in the last 2 weeks. Has a brand new deploy experience, a brand new init experience, which allows you to create new applications locally, a whole bunch of different capabilities for doing testing built into it. So you can test and mock Lambda functions directly in your laptop or your workstation or whatever it is that you write code. And we've got plugins for this with popular IDEs, things like VS Code, and a number of other ones that are out there, or you could just run it as a standalone tool. Cool, so that covers kind of the full scope of profiling, troubleshooting, configuration sharing, secret sharing, monitoring, all that kind of stuff. And so we've added in here now a whole bunch of stuff to these shared services that would impact across this entire architecture that we have between these 2 services. And so what we're left with here at this point is our API gateway, which is going to be kind of the front door of our service, being able to invoke the Lambda function that's got some business logic in, again, our above the waterline public service. That's going to then send messages into EventBridge, so an asynchronous message into an EventBridge, which can then invoke the Lambda function on our behalf. And then we've got a number of shared tools that basically make this all really easy for us. Now, with this, you're not running a single server. You're not setting up a single sidecar. You're not setting up Kubernetes management infrastructure or something like that. All of these things are completely managed. They meet kind of the 4 criteria that we have for what we consider serverless at AWS. And so you're going to be able to build really rich applications, again, without having to do a lot of this other work. So kind of in closing here and talking about building microservices with AWS Lambda, we've gone through a whole bunch of different kind of key points about this, things to think about, considerations that you might have. Again, one of the biggest ones is around what Lambda is, right? It is a serverless, event-driven compute platform. It's got a number of limitations and characteristics to it that make you think differently about how to build your application. We've talked about the different ways that you can expose an API publicly, or even privately, I should say, out to other applications or clients, whether it be mobile, web, or what have you. And talked about the various capabilities and trade-offs and how you can think about them. Again, we just announced the brand new stuff for API Gateway in the last couple hours, so some of this is slightly changed, but still mostly accurate, I would say, in terms of what I shared. We talked about the differences between sync and async. And again, a lot of people have been building synchronous applications for so long that when they start building distributed applications, thinking about async is a pretty big shift to them. But think about those places where you can move to something asynchronous. Think about if it makes sense for you to have a topic, a stream, a queue, or a bus that glues that together for you. And then at the end of the day, with serverless applications, we kind of have this ecosystem around it. So things like X-Ray, all the capabilities of CloudWatch, SAM, CloudFormation, and Secrets Manager, Parameter Store, and so on. And we have these new things like RDS Proxy. We've got the new capabilities for Lambda provision concurrency. And so again, this is a rapidly evolving space. But in the last basically 3 months for Lambda, we've taken the top 3 biggest pain requests from the last year and solved them. So we got rid of VPC cold start pains. We made the pre-warming easier with provision concurrency. And we solved the relational database issue with RDS Proxy. So you should feel confident to be able to build really strong applications now with Lambda. With that, we just want to share that we created some new training that you could find at aws.training. There's a bunch of free training for serverless, great for your organization, for those of your counterparts who didn't make it out to reInvent or who aren't here in this room. If they want to learn a bunch of this stuff, they could find it at the resources listed there. With that, my name is Chris Munns. I lead developer advocacy for serverless at AWS. I really appreciate you coming to this session. Hope you're having a great reInvent. Hope to see you at a future talk. Appreciate your feedback on this talk itself. And with that, enjoy the rest of your day. So thank you.